Let's talk about Ernest Rutherford and how his model of the atom shook up everything we thought we knew about atomic structure. His work laid the foundation for modern atomic theory and even paved the way for quantum mechanics. Rutherford's atomic model 1911. So, here's what happened. In 1911, Rutherford conducted his famous alpha particle scattering experiment. He shot tiny alpha particles at a thin sheet of gold foil, expecting most of them to pass straight through. And they did well, most of them. But a few of those particles bounced back or deflected at sharp angles. That result was totally unexpected and couldn't be explained by the existing plum pudding model from J. Thomson, which imagined atoms as a blob of positive charge with electrons stuck inside like raisins. Rutherford realized something major: the atom is mostly empty space, with a tiny, dense nucleus at the center, holding all the positive charge. The electrons, he proposed, orbit this nucleus like planets around the sun. This was the first idea of a nuclear atom, with a solid center or nucleus, that contains most of the atom's mass. The significance: Rutherford's model was revolutionary. It was the first time anyone suggested that atoms had a nucleus. This became the backbone of what we now know about atomic structure, and set the stage for all future atomic models, including Bohr's model and quantum mechanics. The limitations of Rutherford's model. But here's the catch: Rutherford's model wasn't perfect. According to classical physics, if electrons are orbiting the nucleus, they should be emitting energy and spiraling inward, eventually crashing into the nucleus. Obviously, this doesn't happen. Atoms are stable. So, what was missing? How quantum theory stepped in. This is where quantum theory comes to the rescue. Bohr's atomic model in 1913. Niels Bohr took Rutherford's model and added something revolutionary: quantized orbits. Bohr suggested that electrons can only exist in specific energy levels or orbits. They don't lose energy while they're in these stable orbits. Electrons only jump between these orbits by absorbing or emitting energy, which explains the spectral lines we see. This model explained why atoms are stable and why electrons don't crash into the nucleus. Quantum mechanics. Later on, scientists like Schrödinger and Heisenberg took things further. They introduced the idea that electrons don't move in neat orbits like planets. Instead, electrons behave both as particles and waves and exist in a cloud of probability around the nucleus. In this quantum model, we can only predict where an electron is likely to be, not its exact location or path. Conclusion: Rutherford's atomic model was a game changer. He discovered the nucleus and gave us a whole new way to think about atomic structure. His work laid the groundwork for quantum theory, which later explained the behavior of electrons and why atoms are stable. Thanks to Rutherford's experiment, we now know that atoms are mostly empty space with a dense, positively charged nucleus at the center, a concept that completely transformed our understanding of the atom.